For over 60 years, humans have been putting cameras and sensors into space to look back at our planet. We capture data across the electromagnetic spectrum, from visible wavelengths all the way to the radio wavelengths. In our industry, we call this data Earth observation data. And here at SkyWatch, we take that data and we make it easily accessible for you, our customers, so that you may build valuable applications in the industries that you serve, whether that be agriculture, insurance, or financial services, among many, many more. One of the most common types of satellite data outputs is what we call a true color composite. This is the combination of a red, green, and a blue band from a multispectral imager pressed together to create what we would call a true color image. This is an image that looks no different than any image that you would see on Google Earth or any other mapping service that you use. The most common use case for true color composite imagery is to view change in an area or to monitor the development of an area over time. This could include the monitoring of a construction site, the monitoring of a mining site, or the monitoring of deforestation, among many other use cases. Another popular type of Earth observation product is a false color composite. This is a type of satellite product that includes or can display features that are invisible to the human eye. Such features could include minerals, healthy vegetation, burned ground, and soil moisture, just to name a few. Some of the use cases and benefits of false color composite include monitoring the health of crops using near-infrared bands. And it could include showing vegetation regrowth over time after wildfire, or detecting pollution in the soil from a nearby power plant or mining facility. The use cases for false color composite span dozens and dozens across many, many different industries. In Earth observation, it is also very popular to use the bands from a multispectral sensor to create what we call indexes. Indexes are used to better discriminate the differences between features and highlight changes over time of a particular area. The most common index is the Normalized Vegetation Differential Index, otherwise known as NDVI. Some of the use cases or benefits of an NDVI satellite product include monitoring the health of crops to optimize fertilizer and water usage, identify crops that have been attacked by pests and diseases, or assessing the impact of a wildfire using what we call Normalized Burn Ratio Index, the NBRI. There are many dozens of different types of indexes used across many dozens of industries and verticals. Thermal imaging is another popular form of Earth observation, used in instances in which we need to measure the temperature variation of something on the ground, or we need to be able to see through some obscurity being created by either clouds, smoke, or other limiters. Some examples include the ability to monitor a wildfire through the smoke being created by that fire. Another example is being able to detect the heat by monitoring the rate at which water evaporates from the ground. Imagine a wildfire raging, creating massive amounts of smoke in the sky. In Earth observation, the way we monitor that wildfire is using a thermal infrared sensor. That sensor allows us to view the heat being emitted from those fires through the clouds. Shortwave infrared, otherwise known as SWIR, is a type of imaging in Earth observation that allows us to penetrate thin clouds and do things like identify interesting minerals and possible new dig sites, identify new illegal constructions quicker in areas often covered by clouds, and detect oil spills next to pipelines and other oil infrastructure. Synthetic aperture radar, otherwise known as SAR, is a type of Earth observation collection which allows us to peer through clouds and image our planet day and night. This can be used for use cases such as monitoring floods in near real time, tracking ground deformation, and map volcanic eruptions even. At any point in time, over 70% of the world's landmass is covered by clouds. This makes it very difficult for most satellites to image our planet. That's where synthetic aperture radar, otherwise known as SAR, comes in. SAR provides high or low resolution imaging capabilities day and night and in a way that is weather independent. That's right, it can see through clouds. Radar satellites are particularly well suited for surveillance of vast lands with limited above ground distinct features such as glaciers and deserts.